and Assalamualaikum. My name is Muhammad Irfan Sakhawi bin Muhammad Azlan. I am a first year student from School of Physics. I am major in Geophysics and I am the scriptwriter for this group.
Hi, good morning. My name is Sharvin Rao, son of Suresh Rao, and I am a first year student from School of Physics, currently doing my course in Geophysics course, and I am the presenter of this video.
Hi and Assalamualaikum. I am Haziq Syamil bin Johar. I'm a first year from School of Physics and majoring in Geophysics. I'm an editor of this video.
Okay, so first let's take a look at what is an RF attenuator. So RF stands for radio frequency. So an RF attenuator is an electronic device used to reduce the power or amplitude of an RF signal while maintaining its original waveform. It is commonly employed in RF and microwave system to control signal levels, prevent overloading of sensitive components, match signal levels between different stages of a circuit, and to improve system performance. So attenuators are passive devices that do not require a source or active circuitry to function. They just work by dissipating or absorbing a portion of the signal power passing through them, converting it into heat. So the remaining signal power continues its path but with reduced amplitude. So next, let's take a look at how does this device works. So an RF attenuator works by using passive components such as resistors to absorb and dissipate a portion of RF signal power passing through them. The resistors used in attenuators are designed to have specific impedance values that match the impedance of the RF circuitry or transmission line being used. So when an RF signal enters an attenuator, it encounters the resistors network. The resistors are configured in such a way that they create a voltage divider circuit. The RF signal is divided between the attenuator's input and output ports with a portion of the signal passing through the resistor and the rest continuing to the output. So when it comes to electronic devices, we know that there are no electronic device which can work 100% perfectly. There are always ups and downs of an electronic devices. So same goes for the RF attenuator. It offers several advantages and disadvantages of it. So let's explore a few of them. So first, let's take a look at the advantages of using an RF attenuator. So the first one is signal level control. So attenuators enable precise control over signal levels by reducing the power or amplitude of RF signals. This control is crucial in maintaining signal integrity, preventing overloading of components and optimizing system performance. So the second advantages is called signal conditioning. So attenuators can be used to adjust the signal strength to match the input requirements of downstream devices or systems, helping to achieve optimal signal to noise ratios and avoiding saturation or distortion. So the third advantages is called test and measurement. So attenuators are widely used in RF testing and measurement setups. They allow precise calibration of test equipment, stimulate real-world signal conditions, and enable accurate measurements across different power levels. So next, let's take a look at the disadvantages of RF attenuator. So the first disadvantage is called signal loss. So attenuators introduce signal loss due to the dissipation of power as heat. So this loss can affect the overall signal quality, reducing the signal to noise ratio and potentially impacting system performance. So the second disadvantage is called limited attenuation range. So attenuators have finite range of attenuation levels they can achieve. Depending on the design and specification of the attenuator, there may be limitations on the maximum or minimum attenuation that they can achieve. And the third disadvantage is called cost and size. So attenuators can add cost and occupy physical space in RF systems. High performance attenuators capable of handling high power levels of multiple frequency bands can be relatively expensive and require large physical footprints. So after all we have gone through, we can come to a conclusion that an RF attenuator is a versatile electronic device used to control and reduce the power of RF signals. It allows for precise adjustment of signal levels, impedance matching, and signal conditioning in various applications. RF attenuators offer advantages such as signal level control and compatibility with different systems. However, they may introduce signal loss and have limitations in attenuation range and frequency dependency. So overall, RF attenuators are essential tools for managing RF signal power and optimizing system performance.